So now I can start my talk. So I'm going to talk about the star formation and some observation methods that we use. Okay, now let's move out this stuff here. Okay. So yeah, as I said, when during the presentation or after the presentation, you can ask your questions through Twitter, and this is my Twitter account. So yeah, you can just use it. So as I said, I'm going to talk about the star formation and their observation methods. So okay, let's begin with the stars. So we look at the sky, we see a lot of stuff there. So for example, stars, planets, comets, meteors, and everything. But we are actually a stardust, right? So all the atoms or molecules, not all, but many of the atoms or molecules are actually formed inside the stars. But the thing is, where are these stars coming from? And how did they form? And how many stars are out there? And is there an end? Those kind of questions that we are always asking. So let's start with the definition of a star. So everybody knows what a star is. It's not actually a straightforward question. We just look at the dark sky and we see stars out there, but it's not actually a simple question. So the what we define for a star is the time when its thermonuclear reaction starts. So what happens is so before the thermonuclear reaction starts, we call it star formation phase. Okay, and I'm going to talk about the star formation phase. So do you know what is the lifetime of a star? So for example, sun, how many years does the sun keep living? Anybody say something like 1 billion years? Raise your hand. If you say it's 1 billion years, raise your hand. There is a guy in Iraq, yes. If you say 5 billion years, raise your hand. What is the lifetime of the sun? 5 billion years. Bilkent, Erzurum, yes. Ankara, yes. Ankara, could you move this camera a little bit to the students, towards the students, so that I can see all the students there? Oh my, okay, that's much better, much better, yes. Okay. So yeah, there are some people from Ankara as well. So how about 10 billion years? How many say the solar lifetime is 10 billion years? Selcuk, don't. Okay, yes. Okay, the sun's lifetime is around 10 billion years. But what I'm going to tell you about the star formation and the star formation phase takes only 10 million years. Okay, 10 million years and 10 billion years. So think about this like a baby in the womb. For example, the baby, it takes something like 9 months to grow, and in these 9 months time, baby, the baby feeds from the mother, feeds and breathes, and it gets the water or all the liquids from the mother, so it's not self-sustained. So what we call is like a baby is growing there. So it's like you can compare it with the star formation. Star is actually forming. So when the baby is formed, when the baby is born, what happens? Then the baby can breathe, from the mouth and eat from the mouth. It can just self-sustain. So it can just live by itself, by herself or himself. So you can compare it with the star. And the star is actually, when the thermonuclear reaction starts, then we call it a star. So yeah, don't forget this. The baby takes, something like 9 months to grow in the mother's womb, but the human's lifetime is much longer, maybe like 90 years, 100 years. Just 9 months, 90 years, like 10 million years, 10 billion years. You can just learn it that way. But the thing is, The star, we are, researching on how the stars and planets are forming, but it's really a big problem. It's not really a simple explanation, but it's a big problem. So we continue with the address. So you're in some certain city, and then you're in some certain country, but you're actually on Earth, and Earth actually belongs to a system in the solar system, with the sun rotating it, and the sun is actually inside the Milky Way. So do you know how many stars in our Milky Way galaxy? Milky Way is a galaxy. So who would say something like 1 billion stars? There are 1 billion stars in our galaxy. Who says that? How about 1 million stars? Nobody says that. 1 million stars. 5 billion stars. 5 billion, 10 billion stars. Who says 10 billion stars in our galaxy? Nobody. 100 billion stars. Oh, yeah. Iraq is raising the hand right now. Yeah. Okay. How about Erzurum? Yes, there are actually 100 billion stars in our own galaxy. And do you know how many galaxies out there in space? Something like 100 billion galaxies out there. So just look at this dot here. Actually, you cannot see the dot here because our sun is actually somewhere there, and that place is where our sun is located, but we cannot even see in this picture because we are actually too small in this picture. And yeah, we are just one of those 100 billion stars, and our sun is just one of them. So we are not, we are, it looks like we are not like a very special special thing in the universe. So as I said, we look at the space, you look at the sky in the dark, and we see it's like, oh my God, it's like empty space, it's a dark, black. But the thing is, empty space is not really empty, because even though there is this, even though there, you feel like it's like it should be, empty. No, it cannot be, because there are at least a few particles per cubic centimeter gas in there. At least a few molecules or atoms are there. So nothing is actually empty in space or anywhere anyway. I mean, on Earth, 1 cubic centimeter has trillions of particles. So have you ever heard of nebula? Can you raise your hand? Anyone heard nebula? Oh, okay. Oh, Bilkent, Erzurum has heard of it. Iraq heard of it. So nebulas are like, are like huge clouds. They are actually formed, after the star is dying. So, and they're actually the place where the stars are actually forming. So it's actually, there's an actual cycle. When the stars are dying, when they're dead, then that place becomes the place for the new stars to be born. So there are actually, in this picture, that's a nebula, and in this picture there are actually stars are forming. So I'm going to give you a huge telescope, and I want you to look at one place in this picture, and I want you to find out where stars are forming. So who would turn the telescope to the lower left corner of this picture? There is a little like a cloud there, different cloud there. Who would turn the telescope? I'm giving you the telescope time for free and only once, okay? Just select one region. Who would select, the upper right corner? Nobody? You have a huge telescope. Who would turn the telescope to the center, this shiny, brightest region? Okay, Iraq. Yes. Ankara. Yes. Erzurum. You don't wanna use telescope, Erzurum? How about Erzurum? How about the left upper corner? There are yellow stars there. Okay, just a little, just a few people. Wow, what is this arrow? Are you doing this arrow?
I think Mert is doing that. Anyway.
Okay. I didn't know that we can do this arrow. Okay, nice. So a lot of people actually chose the brightest region in the center, but it's not really the place that I want to look at, because these regions are the place where the stars are actually there. You know, it's not star forming. It's where the stars are already there. So what I want to look at is this picture, this place. So there are actually dark clouds, dark molecular clouds in these nebulas, and these clouds are the places where the stars are actually forming. So I'm going to continue later after I talk about this, how we do the observations. So we use different types of telescopes. How many of you got a telescope? Anybody got a telescope?
No.
Don't worry, I never had a telescope either. You know, I never. I've been an astronomer for 20 years, but I never had a telescope in my life. I mean, like this telescope, of course. But like this telescope, we of course had to use this kind of telescopes, because if you want to research on some subject, you need to have a big telescope. So, for example, this is Gran Telescopio Canarias. It's a telescope in Canary Islands. The mirror size is something like 10.2 meters. So can you imagine, you know, mirror is 10.2 meters. You know, it's probably, you know, from one wall to the other wall in your room. You know, it's huge. And imagine how much, you know, weight it is, you know, to make it, you know, accurately turn into the space. But the thing is, we are not only using optical telescopes. We are also using different types of telescopes, and we actually put different types of instruments to the telescopes. For example, infrared. Have you ever heard infrared? Anybody knows infrared? Raise your hands. Okay, everybody raise their hands. Yes, infrared. You know, infrared cameras are sensitive to the temperature. For example, look at this picture. You know, you look at the cars. For example, the people are inside the car, and you know, it's like, you know, the heat is, you know, much more than outside, so it's much more red. So if you look at the buildings, it's like green, and if you look at the trees, it's like blue. So it's getting colder. So it's actually sensitive to the temperature. So if I want to find out the temperature in somewhere in space, I need to use some different types of telescope, like the infrared telescope, or I'm going to show you another one. So, for example, look at this figure in the sky. So this is the Orion constellation in the space, in the sky. But if you look at this is what we see with our optical eyes. But if our eyes are if our eyes are sensitive to infrared, if our eyes would be sensitive to infrared, the sky would look like just like that. You know, it's going to look like just completely red, and we cannot even see, you know, if there is actually a space out there, because it's completely red, and you know, it's just blocked. So let's continue. Okay, we have, as I said, if I use an optical telescope, I use different things, and then if I use a different type of instrument, I use different things. For example, look at this nebula. So this is called Horsehead Nebula. Have you ever seen this nebula before? It's a very popular one. Anybody, you know, raise your hands. Nobody see Horsehead Nebula, really? Okay, this is one of the most popular one, and the Hubble images. So I mean, the astronomers have really nice imagination, so they can just call the stuff to some real life examples. For example, this is the Horsehead. It really looks like Horsehead, right? So one thing that you need to get out from this slide is you can put different instruments to the telescopes, and with the different types of instruments you see different things in the same region. So in this picture, in the optical, you see like this on the left, and if you put an infrared instrumentation to the telescope, you'll see like this, and then if you have a radio telescope, you see on the right. Okay, and they are completely different pictures, and you really trace and you really analyze or understand, you know, different things in these regions. We are not only having just one type of you know, ground-based telescopes. We also have different types of telescopes, like this, for example, a space telescope, like you see in this picture. For example, the Herschel Space Observatory. That's I actually worked with this telescope for something like 5 years. I'm actually working still with this telescope. So this is the biggest mirror in space. It's a 3.5 meter mirror. So why do you think we need to put the telescopes in space? Okay, just use your imagination. You know, we need to put some of the telescopes in space because we have a lot of atmosphere, and atmosphere has a lot of, you know, water molecules, you know, oxygen molecules, and they are actually, you know, preventing us to see the stars, or preventing us to detect water molecules, for example. So that's why we need to take this telescope above the atmosphere so that we can just observe the stars or galaxies, you know, without the interference of the sky. And apart from that, apart from the space telescopes, for example, there is an STO. You know, there is it's a stratospheric terahertz observatory, for example. It's a telescope actually inside a balloon. We can hear you, but because of internet connections, we can't watch the videos. Was it a news?
It's a very old.
It's a very old.
Yeah, it has been there for 15 minutes.
I just okay. I just so. Okay, there are telescopes like inside the balloon. So think about this huge balloon, and you know, there is this basket where the people are located. You know, where the people are just standing there. So in the basket, we put the telescope inside the basket, and we look at the sky from there. Okay. So normally this kind of you know, balloon telescopes are launched from the South Pole, and it just you know, rotates something like in 2 weeks inside around Antarctic continent. And the other type of telescope is like the plane telescope, aeroplane telescope, like the Sophia. Oops. Okay. Can you actually see? There's a little space at the back of this at the back of this airplane. So it has this 2.5 meter telescope inside this gap, and this telescope can observe stars, you know, very nicely, because it puts something like 99% of the atmosphere below it. And this Sophia telescope is you know, is running from California to, I think, New Zealand a few days a week, so that it continues its observations. So if somebody asks you where is the best observing site in the world, it's the South Pole. It's the Antarctic continent, and the South Pole region is the best ever observing site, because think about like a 3-kilometer high mountain, and it's just ice, nothing else. And especially in the summertime, there is it's actually very clear and dry weather there, so it's the best ever. So the second place is the Atacama Desert in Chile. I mean, think about the mountain. You know, the mountains are usual like this, you know, but this area is something like 5,100 meters high, and At the top of the mountain is just like this, smooth area, so that especially Europe and US are putting their telescopes in this desert. And the third best place is the Mauna Kea mountain in the Hawaii. It's something like 4,200 meters high. So I talked about how the observation methods are, and then we continue how the stars are forming. So I told you, if you remember, I told you there are dark clouds. So why are they dark? Can you imagine why are they dark? Why are they dark to our eyes? Because it just contains a lot of dust and gas. So think about the dust and gas everywhere. What happens? You cannot see far away, right? For example, you are driving in the car, and there are a lot of fog in front of you. So what happens? You cannot see what is in front of you, right? But there is actually something there, but you just cannot see it. It's just like that in this dark clouds. It's just dark. It has a lot of dust and gas, so that in optical eyes we cannot see it. But if we have a radio telescope or a submillimeter type of telescopes, we can actually see what is inside there, and inside there are actually stars are forming. So how stars are forming is these kind of dark clouds are collapsing, and it starts to rotate and rotate and rotate, and then with the rotation it just gets bigger and bigger and bigger, and the stars are forming from there. So how does it initiate? What we call is triggered star formation. So for example, a star, an old star, blasts like a supernova explosion, and then it just creates a shock wave. And then with the shock wave, it just hits hits some nebula, like this here. Oh, I think Mertoja is going to put the video here. Okay, it doesn't work. Don't worry. Does it work? It doesn't work.
Yeah, it's working. It's working.
Is it working? Can you see it?
Yeah, I can see it.
Okay, I cannot see it.
Ankara can see it. Bilkent can see it. Iraq, you saw the video.
Okay,
okay.
Okay. I was thinking it doesn't work, but it worked. Okay, great. So you see that there is a huge a star is exploding, and then the shock wave just hits this nebula, and then it just creates like dense regions, and with this dense regions, it just creates it just starts to form new stars in there. So what happens? And then it continues with this rotation, it's with what we call an accretion disk. So it just creates a disk, and then with this disk, it just gets more and more powerful and bigger in the center. And this disk gets, in the beginning it's very thick disk, and then in time it becomes like a thinner, and then with this thinner disk, it just creates this new planets from these disks, and these planets are like our Earth, are actually forming inside these disks. And in the end, we have the stars like we see in the sky. And I'm telling you this story. It looks like simple, but it's not. It's completely, it's one of the unknowns in the universe. How the stars are forming, how the planets are forming is completely different. It's completely difficult. We have no idea. We know how to form some, little dust particles, and then we know, big rocks, and we know planets. But we have no idea how it's moving from little dust particle to the rock, and from rock to the planet. We have no idea how it happens, but it happens. Obviously, it's everywhere. As I said, it's a huge mystery, and I hope one of you guys will study this in the future. So what do the astrophysicists do? For example, I and Selcuk are like observational astrophysicists. So what we do is we go to some telescopes, or we apply for the telescope time in space or somewhere else, and we do observations basically. But It is a lot of fun. Because we have to go to different places. You know, tropical islands, which is really nice. But it's not always that we do. We always we get this kind of data from there, and you know, these are just numbers. You know, crunching that numbers, and then what we always do is just writing computer programs like this. You know, all the time. You know, we just go to the telescope for 3 days, 3 nights, one week per year, and then the rest of the year we just work on the codes. And then the beautiful thing is in the end we get these kind of images. So imagine the transformation from those numbers and then to this image, which is great, right? I love it, you know. From these kind of images, you can actually, you know, calculate, you know, a lot of things. You know, calculate the mass of the cloud, you know, the density, you know, where the star is actually forming, you know, what's the kinematical information you can get. You know, you can get everything from there. So this is what we do. You know, this is what's basically much more interesting for us. Okay, my last section in my talk is our solar system and what we do at NASA. So you probably know NASA has been around for more than 60-70 years. So, and they had time actually to go to all the planets, and especially they actually go to all the planets. And right now, for example, have you heard of New Horizons? Anybody heard of New Horizon? There is this satellite. It's just almost arriving to Pluto. It's actually going to arrive around July, and it's going to take a lot of nice pictures of Pluto. It's going to be the first time. So, by the way, do you know how many planets are there in our solar system? How many people do you know? Just raise your hands. Is it 9? How many planets are there in our solar system? Is it 9? Is it 8? Oh, some Bilkent is yeah. Bilkent, at the back of Bilkent. Yes, Ankara is now. Iraq. Yes, there are only 8 planets in our solar system right now, because some astronomers changed the history and they demoted Pluto to some minor or dwarf planet. So yeah, there are actually 8 planets in our solar system. Don't forget it. This is important.
Yeah.
And one of the hot topic at NASA is Mars. Actually, the Mars projects are really getting attention. And actually, I can tell you, you know, the Mars is the only planet that's invaded by the robots. You know, there are a lot of robots right there that was invaded by. So I will show you if my come on, my presentation stuck like that. So the idea is.
Can I try?
Can you try, Selcuk? Yeah. So
It's
the
not
idea
working.
is to go to Mars around. It's not working.
Oh yeah. Oh wait. Yep. I think that one, right?
Yeah. What do you see? Do you see the landers?
Yes.
Seriously? Okay, now I can see that. Okay. So the idea is to go to Mars or to land a human on Mars around 2030, 2035, maybe 2040. But we of course need to land a few pathfinders beforehand. For example, previously we could land some, little robots, for example, like this on the left of the slide. This is spirit and opportunity. They were like little robots like this, and when you have a little robot, you can land it like this, like this big balls. You just put the robot inside big balls, and then it just jumps from the space, and then hits the Mars surface, and it's still working. But the thing is, right now, if you remember how Curiosity landed about 2 years ago, Curiosity is as big as a car. Can you imagine? You drop a car from space, and then you expect no damage. And the atmosphere of Mars is something like 1/100th of the Earth. So it's much thinner atmosphere. So when you drop something, it just goes down to the surface very extremely fast. That's why we had to find a different method, and I really want you to watch how the Curiosity land on Mars. It's extreme engineering. It's really it's extremely nice ideas put forwarded, and then it just works. It's a very big mission. And this is the picture from Curiosity. So you think of your robot, arrives to hundreds of millions of kilometers away, and then it just takes a picture just like that, just like you take a picture from your camera, and it's so beautiful done. This is actually a picture from Mars, and it's so nice. And the last thing that I want to mention is the Voyager spacecraft. So it was launched in something like 1977, and the idea was to go to Jupiter and Saturn, and the idea it was to take a picture of there. And then the thing is, it was the time of Carl Sagan, and Carl Sagan was one of the most popular astronomers at the time, and he proposed to put golden plates to this satellite, and there one is for the picture, and the other one has sounds, and you can see it on the right below side of this slide. This satellite actually reached outside the solar system right now. We have a human-made stuff reached outside the solar system, and it's still working. It's still alive. It's giving beep, 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 beep to us, and we can still hear it. It's amazing, Just think about your car from 1977. It still works without changing tires, without putting an oil, without doing anything. It just works from 1977 until now, 2015. And then when Voyager reaches Saturn, the people in NASA asked everyone on Earth to wear nice clothes, get the makeup, and just give a nice cheese to Voyager, because Voyager was supposed to take a picture of Earth, and everybody's supposed to look nice. And this is the picture of Earth from Saturn. So you're actually down there. You cannot even, it's just, we are just like a little dot. Even though if you look at from Saturn, we're just a little dot. Okay, I mean, that means don't exaggerate yourself. We are just a little thing in the universe, and don't think I'm big, be humble. Okay, this is my presentation. Thank you very much. I hope you enjoyed it, and if you have questions, you can send me via Twitter. And now it's Selcuk.
It's my turn. Thank you.
It's your turn.
Okay, my presentation will take about 15 minutes, so just shorter. And then we will move on question section, okay guys? So let's wait for the presentation and start quickly. So everybody's okay, everybody feels energetic and full of energy, everybody's fine. Raise your hand if you are still alive. Awesome, okay. Good. Okay, I'm
What
still
do you
waiting
mean?
for the
What?
presentation.
What do you mean?
They, you know, they could be tired of, you know, listening you. That's why.
What are you talking about? you,
Okay.
you enjoyed it, right? You enjoyed it. Everybody.
Yeah, of course, of course. That was awesome. Yeah, yeah. Yeah, applause
Oh,
for
thank you,
Umut. Yeah.
Okay.
Okay.
Yeah, continue.
Umut, can you see my presentation now? Because I'm not able to see it.
Yes, I can see it. Yeah.
It started already?
Yes.
No. Okay.
Well,
I think I need to
it
wait
says
because.
Galaxies.
Yeah. It says. I know what it says, but it still rotates. Something is still rotating on my screen. So, Tom, are you able to see my presentation properly? No. What about you, David? Can you see it?
Get
Okay.
out of the stuff and come back then. Just refresh the page.
Okay. Yeah.
That's what I did.
I will log out and then come back in 10 seconds. We just sometimes have to do it. Sorry, guys.
Just refresh the page. So let me check if there are questions. I mean, one of the question is Cora Rauf. She says, Dr. Merhabalar, how long does the star formation take? Yeah, I said it takes around 10 million years. It's a very short time scale. Could a person from a higher dimension be able to bend 3D objects just like you can bend paper? I never to the other dimension. No, I really don't have any idea. It's a good question though. Okay, let's check if there are other questions. In the meantime, you can ask questions, just don't hesitate, just conf astro. Okay, you can use the hashtag conf astro as well. Okay.
Oh my goodness, where is Umut disappeared as well? Oh my goodness. Okay, so okay, this is for the first time we are having such technical difficulties. Sorry about that. I still think it is very sad. I only but seems to be back. Awesome. But I can't see my presentation. Goodness. Okay, but Bilkent, Ankara, and Iraq, you can hear me, right, guys? Please raise your hands if you can hear me. Okay. Okay. I think there's a delay. Bilkent, Erzurum, can you hear me? Good. Okay. Okay. Let's move on to West section in this case. Mert hocam kapatalım sunumu. Soru cevap kısmına geçelim. Duruyor. Finally. Awesome. Gosh. Okay. Okay, guys, if you have a question, please come close to the microphone or use the chat box on the left bottom or use Twitter hashtag #EconfAstro to ask your questions. We will read your questions loudly and then answer for everyone. Okay, we have somebody in Ankara, Bilkent. Welcome back, Umut.
Hi. So what happened? Are you not giving the presentation?
No, there's a problem with the presentation, unfortunately. You know, this is for the first time that's happening. That's very sad, very annoying. Anyway, okay, we have a handsome guy in Ankara. Yeah, okay, we are listening you. But now you need to open your sound first. Wait.
Why is it this echo coming from?
There is no echo.
I have a huge echo.
Okay, Iraq says you have a question or...
One question.
Yeah, okay.
My question is about dark matter. What is dark matter, according to recent scientific researches?
Okay, well, the dark matter and dark energy, when you think about it, it is maybe the least known stuff about universe. So the dark matter is basically what holds the galaxies together, okay? But we can't see it. But we can see its effect. Like we are not, able to see black hole, but we can see its effect in the vicinity. The dark matter is when you look at the universe, everything you see using telescopes or different instruments or your eyes is only 4% of the actual universe. So the rest 96% consists of dark matter and dark energy. And about 20% of it is the dark matter. So dark matter is a kind of observational fact. We know that there must be something, but I would say if you go back to 10 years ago and today, there is not much difference between the knowledge that we have. So that's the thing I can answer about dark matter. If Umut wants to add something, feel free, Umut. Umut, can you hear me?
Can you not hear me?
Yeah, I can hear you now. Okay, we have a guy in Ankara. I think he wants to ask a question. If you are ready, you can ask your question. Ankara.
Okay. Do you hear me now?
Yes.
Selcuk, do you hear me?
Yes, I can hear you.
Ankara,
yes.
You can ask. Yes. Okay.
We have a question.
Okay, go for it.
Yes.
Oh. So Ankara, it was the wrong question that you disappeared. So next time think more carefully. And then the question of Ankara was how we disappeared. What would be your answer, Umut?
So, okay, there was a question from Zeynep Serian. I don't know if Zeynep Serian is in Erzurum or Ankara.
No, he's not in. She's not in Erzurum, so probably in Ankara.
No, okay, then we have to wait for her. Okay, Erzurum, you can ask questions.
Yeah, Erzurum, yes.
Erzurum,
you can ask
your
question if you want.
Your mobile.
Ankara, we are waiting for you. Just turn on your camera and microphone.
Arda Hata is in Erzurum or not? Where? Arda is in Erzurum? Is he in Ankara? Okay.
It doesn't matter. Probably he's on Earth, so you can answer the question that probably they can hear you.
I mean, why I cannot? Why should I answer if he doesn't? He can listen to me.
Okay, we have another question, Iraq.
Silly is signing off. We have classes to attend now, so thank you so much for the lecture.
Yeah, sorry for the technical difficulties, you know, that sometimes happens. And thanks for joining us.
Of course. Thank you.
Thanks a lot. Okay, now we have Bilkent, Erzurum, and Ankara. I think we can continue about 30 minutes, right, Umut?
Well,
Okay, Ankara Bilkent asked question using the chat box on the left bottom. So they asked that,
so
do you believe
they can hear us.
life could be sustainable off Titan? Yes, Titan is one of the amazing moons in our solar system, belongs to Saturn, the biggest moon of Saturn, and it really has interesting atmosphere, etc. But I think we just need to make more observation to really understand whether or not there's a life on that moon. And I mean, I have a strong belief that there could be life, like you know, moons of Jupiter, for example, Europa, Ganymede, etc. Particularly Europa could have oceans under the thick ice layers that it has. So yeah, I mean, I can't say for sure, but why not?
Okay, I'll answer Zeynep Serin's question then. Considering the unreliable funding nature of the program, do you honestly believe that Mars One will take off? No. I don't believe that it will work. Not right now. But the idea is, you know, not to send people to some planet and then leave them there alone. The current idea is still put the people, you know, in another planet, either Moon or Mars, and then bring them back on Earth. So that's not the real idea. You cannot just put suicidal people to send to Mars and suicide there. It doesn't work that way. So
yeah, I think there was someone. I think there is someone in Erzurum. Sorry, Umut.
Yeah. Continue.
Yeah, I can see you. Yes. Okay, you can answer. You can ask your question.
Yeah, can you hear me?
Yes.
Yeah.
Okay. Actually, we asked this before, but you know, because of the internet connection, we had some problems. All of us wondered. Only, you know, there was a picture of the solar system, and Pluto also had an orbit around it. And while we were talking about how many planets, it makes 9 with Pluto and 8 without Pluto, and we said 8. I mean, why don't we count Pluto? And what you said
Okay.
about, actually, I
That's
know that's a little bit of complicated, but yeah.
That's a very good question. When Umut and I were students at university in Ankara University, about let's say 2003 and 4, yeah, Pluto was a planet. But in 2006, International Astronomical Union made a definition of a planet, and then it includes 3 little things. If you define something, if you define an object in the sky as a planet, it should have those 3 things. First, it should rotate around the sun. Yes, Pluto does this. There's no problem with that. Second, it should have a spherical shape, because that's a result of a gravity. If you have enough mass, that's the shape you end up with. Okay, yes, Pluto is spherical. There's no problem with it. But the third one is, if you are the biggest object in your orbit around the sun, you either gather all the materials, to you, or you just kick them off. But when you look at the Pluto's orbit, it enters the Kuiper belt and, go out again. It's very close to the Kuiper belts. And then the new observation showed us that there are other planet-like objects there that we call now is the dwarf planet. That's why Pluto is not a planet, but a dwarf planet. But I think there was a meeting at Harvard University, I think last year, and then there were 3 astronomers. One was thinking that Pluto is not a planet, but the other 2 were thinking that the Pluto is a planet. And then they also voted using the guys there in the meeting, and then they decided yes, Pluto is a planet, but it doesn't matter because we don't care what they think, because the only thing that we can take as a reference is the International Astronomical Union. If they decide that Pluto is a planet, yeah, it could be a planet, but if they do that, there are other two dwarf planets which are bigger than Pluto would be planets. So in total, at least we would have at least 10 planets in our solar system. So currently we have 8 planets. Okay, thanks for the question. That's an awesome question. Okay, yeah, Umut.
Okay, there is another question from Arda. When will we be able to colonize Mars? So that's, I think I answered those kind of questions. So we still need to land a lot of robots and a lot of resources to Mars first, and then we should send humans to there, because it's a long journey and people don't go there for a few days and then come back. So people will stay there for some time. So you need to put all those jet engines, the rocket to come back, to all the food, all the water and everything. You have to send it beforehand, and you need to solve how the landing problem as well. Yeah, it takes really long time. It's not really, I mean, the optimistic date or year is something like 2030, but I believe at least 2040, at least. And yeah, it's, in order to work at NASA, what should we study in university? Well, you can study anything basically, as long as it's research based or STEM based, science, engineering, technology, mathematics. Yeah, whatever you study, it's always always a good option. For example, we are an astrophysicist, so astrophysicists are are like like the normal people, that should be there, but it's not like that. The number of astrophysicists are actually quite lower than the engineers. There are a lot of engineers who are working on robotics. They are especially in Jet Propulsion Laboratory, there are a lot of robotics people or software people or engineering people. I mean, much more than half is all engineering. And there are a lot of other fields like geology, earth sciences, oceanography. There are a lot of different topics as well you know are researching here. So you can study anything basically, as long as you have ambition and as long as you wanna yeah, you have questions. Then you should of course try to apply here and try to come here. Yeah, other questions do you have? Erzurum has raised the hand, this blue
Cool,
t-shirt.
yeah. Yeah, ask your question.
Ask me your question. Come to the camera. Ask the question.
It's impossible. I have my microphone. It's okay?
Yeah, we can hear you.
There's a microphone. That's good. Yeah.
Okay then, in the presentation we talk about the formation of planets, and in the formation of the planet, what gives the rotation power to the gas and dust particles to form a planet?
What is the what? What is the?
In the
Yeah,
formation
if
of
you...
planet, we say that gas and dust particles rotate to form a planet. Where this power comes from?
Well, it's not direct. Okay, the gas and dust particles are, in the dark clouds, it first collapses, and then when it starts to collapse, if you remember this triggered star formation movie, so that there is this shock wave actually makes this dense regions, and with these dense regions, a few of this, of these, uh, denser regions are just hit each other, and then it just becomes much bigger, and then it starts to rotate. The problem is, as I said, in the presentation, we have no idea how to convert from very small to very big. It's actually a big transition, and we are trying to find out why is it happening. We know how to form a molecule, we know how to form a little dust, but we have no idea of from dust to bigger stuff. The main thing that we see is just the rotation, the accretion disks, and from the accretion disk we see the stars form and then the planets form. Are there any concerns of introducing foreign biological substances into? Okay, there's another question from Ankara. Are there any concerns of introducing foreign biological substances into Mars's environment surface? Yes, of course, a lot of concerns about it. I remember there was a presentation here. The guy was talking like, what if we are landing, we are sending robots to Mars, but what if a microbe, a bacteria, just stick to the robot, and then that robot and that bacteria keep alive, and then that robot arrives to Mars, and then it lands on Mars, and then we do the digging, in the Mars, and then when you do the digging, you had this bacteria, you had this microbe inside your stuff, inside here, and then you put this soil to the laboratory, the Mars laboratory, and then you find a bacteria, and then and then you say, oh my God, we find bacteria on Mars. It's actually no, you must be extremely careful not sending a human bacteria to Mars and then refinding it there. You should be careful about not sending Earth bacteria, and this is really an important concern. You're asking, yes, concerns. Yes, you shouldn't send it. That's not. That's Earth stuff. Until you send humans to there, then we will destroy Mars, as we destroy Earth today. Okay, other questions? Okay, we will receive just maybe one or two more questions, and I think...
Yeah, I think that there is another question in Erzurum. Yes, I can see you. Yeah, you can ask your question loudly, please.
Can you hear me?
Yes?
Yeah?
What does the universe look like beyond the limits of our visible vision? Don't know. Visible vision, yeah. Like
yeah,
observe. Okay, we call it observable universe. Yeah, we call it observable universe because this is what we can observe, and we have no idea actually, what is not observable, because it's not observable. We cannot see it. We can we can actually create theories about it.
Actually, sorry, Umut. Actually, my presentation was about it a little bit, because I was talking about the observable universe and the universe itself and expanding universe, etc. So when you look at the observable universe, we know its size and then its age. But the outside of this observable universe that we call those observable universe Hubble sphere, okay, and it's expanding as we speak. But you can simply assume that the universe, the whole universe, is just infinite. You can simply assume that. Or you can even assume that the parallel universes as well. But anything you say outside the observable universe is just just a word. So you are free to say anything you want. But what we can talk about physically, what we measure, if you measure something, you know, if you analyze something, if you have numbers, if you have something, then you can talk about it. But that's the observable universe. We can talk about it. But you know, we don't know anything about the outside of the observable universe. But of course, there are some theories about it, but we are not sure. Yeah, now my presentation is working, ironically.
Ya aç şey yap. Gerek yok artık yani. Gerek yok.
Yeah, I agree with that. Yeah, that's the Hubble sphere, and then let's look at this just size of the observable universe. It is like 93 billion times 10 trillion kilometers. So if we go back, we use light years. Anyone knows what is light year is? What light year is? Do you know it? Do you know that? Okay. It's the time a light, you know, takes if it goes like for 1 year. So it goes light years, about 10 trillion kilometers. So we know the diameter of the observable universe. But outside this, that black region, let's say, we have no idea. Of course, we have some theories. Anyway, yeah. Okay, I think we can have some other questions. Tom and David, you can also ask questions if you want, if you have any. And Ankara Bilkent, can space-time have a negative curvature? Well, that's a very cool theoretical question to ask the observational guys. Yeah, but now, Ankara, I can answer your question like that. Now, according to last results, current results, universe, I mean, the observable universe is flat. We can't see that curvature in bigger scale because I think the universe itself is so infinite. That's why you are not able to see the curvature if there is. So we assume that the universe is flat. But I don't know whether or not it could have negative curvature or not. First question? What was the first question? Okay, wait. Can we apply star formation principle to ideas like the creation of the universe? Yes, I think so. Because when you look at the star formation, you know, you need to gather material, you know, you need to collapse it to form star. And then when you look at the formation of galaxies, you need voids in space, okay, the regions with less density, that you can gather the material again. It's exactly the same process. But when you look at the creation of the universe, I think it's different, right? Because we are assuming that if the universe is expanding, there must be a starting point. That's the beginning of the idea of Big Bang. If there's a Big Bang, like the, you know, very small volume, like the size of a neutron, you have everything. After a very, I think it's not really the correct way of calling it bang, because it's not a bang. It's a very rapid expansion. Okay? So I think there are some differences. Yeah, I mean, you should not compare two things like they are the same. No, they are not the same. They are different processes.
Okay, now I'm at 1 o'clock right now. Your daytime right now, I guess.
Yeah, guys, I mean, can you ask your questions
So
using our Twitter
we can actually end the
account?
presentations and the conference, but you can still ask questions via Twitter or email, always, anytime, not only related to
I also like to share with you my...
So just ask anytime. And if you want to become, you know, if you're interested in space sciences or something like that, yeah, we would appreciate it. And yeah, thank you very much for listening.
Yeah, okay, and I'm copying and pasting my YouTube channel address here, because I am putting some videos, short videos about some interesting stuff about the universe and astronomy in general. But for English speakers, sorry, all the videos are in Turkish. But there, of course, there are some nice videos and etc. So I will put the next. Yeah. Okay, Umut. Okay,
yeah.
Umut.
Now everybody comes to the camera so that we can take a selfie picture.
Yeah, that's
Okay,
what we do. At
yeah,
the end
now
of
everybody
each talk, yeah, come
everybody
closer to
stand
the
up.
camera, come closer to the camera,
Come
and
closer to the
show
camera.
show your energy to us, okay? And then we will take a picture, screenshot from here. Awesome. Where are you, Mert Hoca? Mert Hoca, come
Yeah.
here. Yes, our coordinator,
Bilkent.
Mert Koçer, is here. He's rocking. Okay, cool. Okay, guys, now you can, shake your hands, just smile, just scream, just full of energy. That's what we want to see, okay?
Erzurum, come closer, Erzurum. Come closer. No, look at us, not the screen. Look at us. You're looking at the screen. Just look at us. Look at the camera. Yeah. Come here. This direction. No, the other direction. No. Yes, here.
Okay, guys. Now,
The camera.
yeah, everybody at the same time.
Yes.
Yeah, shake your hands.
Look at the camera. Yes.
Awesome. Awesome, guys. Thanks.
Take a picture. Take a picture in the classroom as well. Then send it to us as well.
Yeah, and the last thing that I like you to do, please,
Send it via Twitter.
Okay,
Shut up.
guys.
Shut
Well,
up.
this is the first time that we gave this e-conference in English. So please go our website, which is where is our website, Mert Hoca? Go our website and fill the form and let us know your opinion, okay? This is very important. Except technical difficulties, okay? Please let us know your opinions, which are very important.
Yes.
Okay, guys? Thanks for joining us. You are full of energy. You are the future of this beautiful country and this beautiful planet. Thank you. Thank you, Tom. Thank you, David. And see you maybe in the future in different projects. So we can start. Cool. Okay, I'm gonna give you the program of today. Okay, shortly. Okay, first you will watch two short videos. One of them is about the Caltech, NASA, the place where Umut is working right now. And the second video will be about a competition that I attended 2 years ago, which was about the going up to space. So, however, unfortunately, I didn't have enough time to make the video or to add English subtitles to the video, unfortunately, but half of the video already is in English. So for English speakers, it should be fine, I think. After the videos, the total, it should take about 12 minutes in total for both videos. And then we will give a presentation. Umut first will talk about the star formation and different types of telescopes that we are using. And then I will talk about universe and galaxies in general. So those two presentations should take about 40 minutes, and then we will move on the questions section. So you can ask any questions you want. Okay, so I think we can start.
One thing I have to, one thing I want to remind you. So normally we expect you to ask questions via microphone from your connections, but sometimes there are a lot of questions, and you can also ask the questions via Twitter. So you will see our Twitter accounts in our presentations or so. So yeah, you can please go ahead and ask questions via Twitter as well, if you cannot have the opportunity.
And one important thing as well, thanks for reminding me, during the presentations we sometimes ask a question to you. And then what you need to do is just raise your hand if you agree with the question, okay? So please raise your hand if you have an answer for the question that we will ask you. So it's kind of a way of communicating with you, okay, using your body language, because we can't hear you to prevent this from echo. So please join us. Okay. Mert hocam, başlayabiliriz. Okay, let's start.
Good afternoon, everyone. I'm Buzz Aldrin. 44 years ago, I made a brave decision to journey into space, and it changed my life forever. And now you too can become a member of this privileged group and experience everything that I have. The Apollo Space Academy is looking for regular people like you to go into space. If selected, you'll be sent to our space camp in Florida for rigorous astronaut training. The top recruits will then be rocketed into suborbit in an SXC spacecraft. Are you ready to make history? Then join the Apollo Space Academy and leave a man come back a hero. Good luck, everyone.
Yeah. I have Ukraine too.
It's like come to the ecstasy to life for them. It's like
La 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 la.
Give it up for Turkey. Where's up?
And that'll be the floating for about 10 seconds is all you'll get. The main thing, when we strap you into the cockpit, we're going to have that lap belt nice and secure on you so that you don't, you
Zero G, ready?
Okay.
Okay.
We're going to be departing out to the west. Okay.
That's something.
4G turn.
Okay. There we go for a 4G turn.
Yeah!
There's one more. All set?
All set.
Okay, I just want to know, get a little more speed and all. That's it. Speeding traffic, experimental restriction.
Oh my god. Oh my god, you have the most amazing job.
That's great.
You crazy. Woo, that's cool.
Here, Romeo is...
Let's do it again.
That's great. That's fun, huh?
Yes, sir, it is.